The William C. Daldy recently made the bold call to move from coal to renewable fuel. In April 2025, we conducted a back-to-back sea trial of the briquette product, made from upcycled wood waste. The trial proved not just that the conversion could be successful, but that it could potentially improve on the coal experience. Briquettes are manufactured from joinery factory wood waste, which would otherwise go to landfill. The waste arrives at the briquette factory in shipping containers, ready to feed the processing machinery. The waste travels up conveyor belts to the hopper, where an auger feeds the raw materials to the processing machine. Inside the machine, another auger carries the material to the briquette press. Inside the press, the waste is forced at 100 times atmospheric pressure through a heater, which heats the material to around 100 degrees. At this point, the resin in the wood has become viscous and will bind the material together. From the heater, the material is forced into the die. Inside the die, friction heats the material to 250 degrees or more, shedding moisture on its way to the cooling conveyor as a continuous log. At the end of the cooling conveyor, a guillotine severs the log into manageable lengths, dropping them onto the lower end of the packing conveyor. The briquettes are carried up the conveyor, falling into the shipping bags. Aboard the Daldy, the crew loads the bags of briquettes, each weighing around 800 kilograms, into the ship's fuel bunkers. It's important to understand the comparison between briquettes, wood and coal. Nothing but heat and pressure are applied to the raw wood waste, but briquettes cannot be compared with wood. The sub-bituminous coal we used to burn typically contained between 10 and 25% moisture. The briquettes contain less than 8.8%, contributing to less overall smoke production. The ash content of briquettes is just 1.3%, a fraction of the 10% plus that's typical of coal. This ash has long been a bugbear of the Daldy volunteers. Volunteers would have to manually remove hundreds of litres of ash and clinker or slag from the depths of the boiler room stokehold after every sailing. Briquettes are typically yielding only about 10% of the ash produced by coal. Anything that burns creates byproducts. Being a fossil fuel like diesel, coal smoke contains sulfur dioxide with an obvious odour that causes respiratory irritation and nausea. In the atmosphere, it contributes to acid rain. The briquettes, by contrast, are practically odourless. From the outset, people were sceptical that briquettes could make the same heat as coal, but the numbers tell a different story. Briquettes contain 20 megajoules of energy per kilogram. That's right in the middle of the range typical of coal, which industry assesses at an average 24 megajoules per kilogram. Those figures equate with our experience. The briquettes burn hotter but also faster than coal. It appears we're using 1.2 tonnes of briquettes for every tonne of coal we would previously have burned. In a normal season, we would expect to remove 150 to 200 tonnes of wood waste from landfill. When the William C. Daldy was commissioned in 1935, coal smoke was literally everywhere. Hospitals, schools, factories and industry, ships and tugs. Coal smoke was almost accepted. The risks were not unknown, but there were no practical alternatives, and it was tolerated. What we've learned through the adoption of briquettes is that our environmental footprint is something we can manage. Excessive and dark smoke anywhere is always evidence of incomplete combustion. By carefully maintaining the temperature of our furnaces, we can almost completely eliminate the appearance of smoke from the ship's funnel. We've been conducting detailed analysis to perfect the techniques we need to perform at our best, cleanest and most efficient. We're installing instruments to implement our learnings and regulate our operations. We believe the William C. Daldy will be the greenest vessel of her type on the Waitemata.